Let's talk about the scalability and concurrency now. So there are two types of scalability we have. One is called vertically and the another one is horizontally. So in Lambda terms, when we talk about the vertical scalability, we need to increase the memory resource for the particular function. Now there is a upper limit in vertical scaling. Lambda does support currently a 3 GB memory as a vertical limit. So you can scale up only up to the 3 GB for a function. If you have a requirement where you need more than 3 GB memory, then you have to split your functionality in multiple Lambda functions and then you can execute it. Now let's talk about the second type of scalability, which is horizontal scalability. Now if your Lambda execution increases and your current container which can have maximum only 3 GB memory cannot handle it, then it is going to automatically spin up other instances to handle the execution load. So in Lambda, the unit of scalability is equivalent to unit of concurrency execution. So the number of concurrent execution you want to do, accordingly the container will be spinned up. But as I mentioned that no service can provide you infinite resources, and the same applies to the Lambda as well. So there are two levels of limit we do have in Lambda. The first one is at account level, which is 1000 per region per second is the concurrency limit. So you cannot run more than 1000 concurrent execution for your Lambda functions. The second limit is function level limit. So function by default uses the unreserved account level concurrency limit. For example, if you have two functions, one function has been defined with 10 as a concurrency limit, then the 990 remaining limit can be used by another function. Now if you can see, if we don't allocate any account level limit, then the function can use up to 990, or if I don't define even the first one, it can take up to 1000 limit. So it is not a good practice to use the unreserved account level limit, because if for any reason the number of concurrent execution has been increased for a particular function which exhausts all the limit, then it can cause the throttling for all the other functions and they will not be able to entertain any request. To avoid this issue, we should always be defining at function level limit. So let me just quickly show you how we can define the concurrency limit. So if you open any Lambda function, you will see this section concurrency, and by default you will see this option enabled. So this will be using the unreserved account concurrency, which is right now the limit is 1000. And as I explained, the best practice is that you should always define your concurrency, how much the maximum concurrent execution you are expecting for your function to handle should be defined here. Now if it breaches that limit, it will cause to have a throttling, and that you have to handle at the function level. which we'll talk about in our next chapter. But for time being, you just remember that there are two level of limits we have in Lambda for concurrency at account level and at the function level. Now let's take an example. If we are running the Lambda in VPC, now in this case, these limits will not apply because in VPC it will consider the VPC limits for Lambda execution. Now when you invoke any Lambda function in a VPC, the Lambda set up a Elastic Network Interface ENI, which helps to have a communication among all the AWS services in a secure way. And each ENI will be requiring one private IP address. Now each VPC will have a limit how much maximum IP address they can have. So when you are running your Lambda and VPC, you need to calculate your ENI capacity. By default, the network interface limit for a particular region is 350. But you can use this formula to calculate how much capacity you would be needing. So the formula has concurrent executions multiplied by memory in GB divided by 3 GB. Here the concurrent execution means that how much concurrency workload you are expecting. So it means how many invocation per second for your Lambda function you are expecting, and then how much average time your Lambda function takes to execute. The memory in GB is nothing but how much memory your Lambda function would be requiring to execute your logic. So based on this formula, you can calculate how much ENI capacity you would need, and based on that how many IP addresses you would need to allocate in your VPC. There is one more thing you need to consider while you are designing for your concurrency. That if your Lambda is using any other services like DynamoDB or any other database connection in VPC, then how many maximum connection DynamoDB or other DB services can accept. You have to apply auto scaling feature over there. So these are all the points we need to consider while designing our scalability and concurrency around Lambda. Let's move to the next chapter, throttling.